All right, we'll do it. F it. F it. We'll do it live then. We'll do it live. All righty. We'll do it live.
Just a good old smash. Never meaning no harm. Beats all you never saw. Been in trouble on social media since before its existence. Straightening facts. Smacking down hacks. Someday our viewers might get me, but pretend never will. Making my way the only way I know how. That's just a little bit more than Big Tech will allow. Just a good old smash. Wouldn't change if I could. Fighting the nonsense, it's a neo-renaissance in the hood.
Like I said, we'll do it live, okay? We'll all write it.
Just kidding, folks. I'm not even mad. I'm not even mad at all. I was just joking around. Anyway, we've got a coronal mass ejection to analyze here, so let's get to that. Might be interesting. So, first thing I'm going to do is I'm going to head to smAshomash.com and buy some merch. No, I'm just kidding. I'm going to head to the Integrated Space Weather Analysis Center. And I'm going to put on my shades. Please leave us a comment if your future is so bright that you've got to wear some. Who made that crappy 80s song? Was that Corey Hart? Leave us a comment if you know who that was. So here we are at the Integrated Space Weather Analysis Center. Let's take a look at the LASCO C2. As we saw the coronal mass ejection incredibly slowly coming out of the western limb on stereo A, and it looks like it's coming out of the western limb here on the Soho LASCO C2 as well. That ejection is not ejected yet. That is still hanging out. So usually we see these rather violently propagate by now in terms of, that's like 3 solar diameters, folks. We normally see that propagate by now. So I'm going to cut back to that in a minute here. First, we're going to go to warp speed to make sure that we escape at all costs. Just kidding, folks. It's not looking particularly dangerous. It looks like it's going to come out of the western limb. But again, this is a big one, and it's propagating over a long period of time here. So again, we saw 2 C-class solar flares. If you don't watch our daily space weather videos, there's a whole playlist at youtube.com/smAshomash/playlists. It's got right about 600 videos on it now. There are actually even more than that if you go all the way down to the bottom of our list of videos. And we're looking at ancient data here. Ancient data. Because reasons. All right, here's the LASCO C3. So now we're back to Lagrange point 1. Stereo A is at Lagrange point 5. And for some reason, it's showing us ancient data from like 3 days ago. Now we're going to go to Lagrange point 1, where we started things out, the LASCO C2. Now we're going to look at the LASCO C3, a zoomed out image of the same thing. You can also see Venus there. And yeah, this coronal mass ejection has not yet ejected, as far as we can tell. Let me actually go back to the C2 and bring that back. I'm going to take some earlier images than that. We'll go back 50 frames. And there you can see that coronal mass ejection starting to propagate out. And thanks for tuning in and leaving comments. Pop Smith, Chicken Little, Che Stevenson, and whoever else might be hanging out. So let me see if I can find something from stereo A here, as this is, here we go, that looks like something. All right. There we have some legit imagery. That's going up until about 1 p.m. Universal Time there. So it looks like that is, I think that is a complete ejection now. It looks really diffuse and very, very low speed. So let's go back a little bit in time here, 50 frames before the current frame. Put your chats back on the screen. And again, if you're viewing live, leave us a comment. As we do a little bit of analysis here on the, well, really it's an ongoing coronal mass ejection event here. So we have to keep watching the LASCO C2 and the LASCO C3 here, as we don't necessarily have a very good idea of the directional nature of this one. This is still, there still appears to be some filamentary material anchored to the corona. Maybe not anchored to it, but still in the corona. And from this perspective, you can't really see the full size of this. You can't really see it properly except from stereo A. So when you look at stereo A, just a quick little reminder. This right here, this is the solar diameter. That's like the edge of the chromosphere, you could say. And so this is like, as you can see there, the latest image there is about 2 hours old, but the latest image there showing at 11 o'clock Universal Time. That's like 4 solar diameters, and we still see parts of that in the corona. So there could still be some of this being pulled out of the corona as we make the video here. It's really unclear. So, but the stereo A difference imagery does show that it's, you can see how diffuse it becomes. It becomes very, very diffuse there in the difference imagery. And the difference imagery is just pixels subtracted from previous pixels, essentially. Sometimes it shows you a lot more contrast. It looks like there's material coming out of the opposite side of the sun as well. So that's more indication that this particular coronal mass ejection, if you look over in this area here, I think this particular coronal mass ejection is entirely westward of earthly locales. If you look over here, you can clearly see that there is some material associated with that same event. But again, the fact that it hasn't fully ejected yet, at least from the perspective of stereo A, and from the perspective of the Lagrangian 0.1 LASCO C2, it's a little too early to actually try to calculate the trajectory of this one here. And we can't really go into how we forecast coronal mass ejections. And by the way, when I talk about forecasting coronal mass ejections, I'm talking about forecasting a coronal mass ejection before one occurs, as that is what we call pushing the boundaries of predictability. And so here at the Smash News Network, we're quite interested in predictive value. So just to tie that into our mission, and you can read about our mission on our own website, which would be the official website of SNN, the Smash News Network, smAsho.com. And the mission's available from our forum. So there's no link to it. You would have to type in smAsho.com/forum/mission. And you'll find our mission there. And the forecasting of coronal mass ejections brings me to number 6. Because what we're interested in is assisting mankind, or womankind, or androgynous being kind, or any kind of anybody, by advancing the study of what we call predictive phenomenon. So there's a reason why we look at the variables that we do on the daily, but we also look at a lot of other things. So we're interested in predictive value, phenomenon with predictive value, in order to optimize things like physical value, reduce risk and liability, save lives and resources, and adapt no matter what the adversity is. Again, if you want to read more about the mission, it's all available at smAsho.com/forum/mission. And while we are not yet a nonprofit organization, if you type in smAshomash.org, it's going to redirect you to smAshomash.com because we're using our current leveraged assets in order to become a nonprofit organization, but we aren't yet. So don't let smAshomash.org fool you. We are not yet a 503c organization. That is coming. We just need a little more funding, which we're always looking into. Also, folks, if you need a website built, drop us a line anywhere, and we'll build a website for you. It's the latest sector of business that we've jumped into. So if you have a website you want built, drop us a line. You can find us all over social media underneath that arrow. And enough on plugging us. Let's go take a look at what the local yellow dwarf is doing here. We're going to look at just the imagery from today in various wavelengths. So we're going to start out at 94 angstroms. And then I'll put your chats back up on the screen to use this as a nice animated background. We'll shrink it down to a slightly zoomed in equatorial view. What say you, the viewer? What are you into on this delightful Sunday? Again, predicting that coronal mass ejection to miss Earth to the west. And reminding our viewers that when we say predict coronal mass ejections, I'm talking about predict them before they occur. Part of the reason we're the least busted name in news. And of course, that's only one of the features that we look at. We're also looking at various climate data and so on. We even have been known to look at economic data now and then, since, hey, the largest cyclic aspect of human civilization would seem to be solar activity, perhaps. And so don't forget to inform Peter Schiff of our videos. If you follow Peter Schiff on Twitter, tell him to watch our daily space weather videos. We'll probably be forecasting coronal mass ejections before anybody else. And people like Mr. Schiff would prefer to have advanced warning. For example, if the Puerto Rican power grid goes down, which is where Peter Schiff lives, by the way. So, by the way, there is a significant possibility for lots of additional solar flares here. Despite that sunspot moving out of the Earth-facing zone, we see a lot of filaments in between Earth and Sun right now. And you can see several dark spots here in this SDO 304 angstroms image. You can see a bunch of dark spots. It's an upside-down mean smiley face. All right. And you actually got a view of those one of those C-class solar flares, which happened earlier this morning at about just before 7 o'clock Universal Time. See that brightening there near the limb of sunspot 2804. And we're going to actually show some additional wavelengths here since we're streaming live. We didn't show 335 in the daily space weather video, so here's 335 angstroms. There's 335. And by the way, these colors aren't really these colors, folks. These are artificial colors. We could make it whatever color we want. And I don't have any like live streaming color overlay software installed or anything like that. But the point is, you can't see any of these colors. These colors are extreme ultraviolet colors emitted by all of those ions. So this particular one is 335 angstroms, which is iron, ionized 15 times, iron 16. And you can find all that at the SDO The Sun Now page on their fantastic website. And I guess we'll zoom in on 335 angstroms. I would note once again, you can see filaments up here that are still on the corona. Or you could say in the corona, rather. In the corona, on the corona, around the corona. But have not been yet ejected from the corona, is my point. And you'll see some large filaments down here as well. Here, I'll move the screen instead of the arrow. There you go. Some filaments in this area. And by the way, if you ever want to just look this up real easily, just look up the synoptic map. And you'll find this map. It'll show you the coronal holes, and I think they're even their numbers. Let me see here. I believe that's the coronal hole number, yeah. And I think I blew my shoulder out or something, folks. I've got muscular pains. I need a massage. Is there anybody out there watching the video? Leave us a comment. As I have no idea how many viewers we have. I think I see 9 people. Drop us a line. Tell us what you're into. How about a composite image? Here is 211, 193, and maybe not. How about 304, 211, and 171? I would remind our viewers here that this one actually has different colors than you normally see. Normally 211 is sort of a purplish color. And normally on the SDO, 171 is usually gold, not blue. So as you can see, artificial colors here to represent tiny bands, very specific bands of the UV electromagnetic spectrum, giving us a little insight into things that are going on. And of course, coronal holes have really emerged as one of the most important phenomena that we see on the solar disk, such as this one down here, which will be providing a solar wind in a couple of days. We should see an increase in geomagnetic activity, even possibly a low-level geomagnetic storm from this one. Although the crossing of the current sheet may affect that, it could cause a downgrade because of the North Pole current sheet. And the Earth is very close to crossing into that current sheet right now. So that's going to have some significant effects on the orientation and possibly even the directional aspects of this coronal hole wind stream. And for you viewers who have no idea what I'm talking about, this is the heliospheric current sheet right here. And here you can see the Earth is just approaching this crossover line here in between the South and North Pole current sheet. So by the time we do tomorrow's daily space weather video, I would expect most likely, I'll say 95% chance the Earth will be in this green North Pole current sheet, and that should be before the coronal hole wind stream arrives. The forecast for that is for it to arrive late tomorrow. And we're only expecting minor geomagnetic storms from that, not really any power outages, period, from that. When we do see power outages, we typically see those in places with less sophisticated grids. So the U.S. is much, much less susceptible to grid failure than a lot of other places. I know the last major one that seemed to be solar-oriented was, I believe, an outage in Ecuador, if I remember correctly. I do not remember when that happened. So, as our regular viewers are probably well aware, coronal mass ejections, which are material, mostly hydrogen nuclei, blasting out of the sun's atmosphere, known as the corona, sometimes at nearly light speed, but usually only around the speed of the solar wind, so a few hundred kilometers per second, similar to the solar wind speed, but different than the solar wind speed. And when this happens, these things typically propagate out like a bubble, like this, and then they become more and more diffuse as they propagate out through the solar system. Sometimes they strike the Earth, and when those hydrogen nuclei show up and they find a lot of chemicals, they want to react with the chemicals. I can't put it any simpler than that. The breaking radiation caused by these particles striking the Earth's outer atmosphere layers and so on, called Bremsstrahlung, the breaking radiation, are what cause these changes in the Earth's magnetosphere, magnetic induction, and yes, aspects of the universe are indeed electric. The universe as a whole isn't electric, but portions of it are. So the Earth's atmosphere is a capacitor in between the core of the planet and space, and that's part of what's going on there. Actually, let's take a look at the magnetosphere so you can visualize what I just explained in a more visually visualized vision. Visualize your vision. And once your vision's visualized, you'll be in a different quantum universe. If you don't like the place in which you're located, take a deep breath and chill out. It'll be a totally different place in a matter of seconds. Celebrate the past because you're already thinking about it now. And we see a high velocity zone here near the magnetotail. And that's the portion of the magnetosphere where the solar wind starts pulling a bit of matter back into it, which causes induction. And it causes those speeds to be accelerated as they reintegrate to the solar wind at the magnetotail. It's not an indication that Nibiru is behind the Earth. And by the way, if Nibiru was behind the Earth, it would be super obvious, because people would see it with backyard telescopes. But Nibiru's dark. Yes, I know, Nibiru's dark. It doesn't emit any light, but it would still cause occultation, and people would notice stars are being blocked by something. People notice little tiny asteroids with backyard telescopes through the process of occultation. And I've never heard anybody argue the theory that Nibiru is out there after they heard about occultation. If you're looking at these stars, let me just explain this to all of you Nibiru people. If you're looking at these stars, and a thing the size of a planet moves across the stars, if you have sophisticated equipment that's taking video, you'll be able to calculate the motion of this thing. And everybody would know that it's there, and it would be super obvious. Nobody's hiding Nibiru. Nibiru is simply not a thing. All right, now that we've covered that, what else do you want to talk about Should we talk about crypto prices? I guess I won't talk about crypto prices. I've entitled this video something to the effect of Daily Space Weather YouTube exclusive live stream, CME analysis, viewer chat, and solar flares. Did you know about the solar flares that happened? We saw the largest solar flares happen in the past 24 hours that have occurred in months. Yeah, months, I think. Pretty sure months. Anyway, there's the 3-day chart. And I'll bet there is a site that has the X-ray flares, the solar X-ray flux plotted over a period of months or years or decades. I just have no idea. How about solon.info? I don't know. They've got a lot of information there. Solar wind, electron flux. Let's see if there's any new updates. Comparison of cycles 24 and 25. Yowzers. Cycle 25 not getting off to as stellar of a start as it looked like it was initially, but still looking a little stronger than cycle 24. You can also find information on solon.info about the solar polar fields. And let me just bring up a very important chart here, since we're about to explain the solar cycles, just not in this video. The Wilcox Observatory, are you familiar with it? The Wilcox Observatory has the long scale magnetic data. Oops. That was the absolutely wrong thing. Here we go. That was the wrong thing too. It's got all of the here we go. What in the heck? Please bear with me as we're having some technical difficulties right now. All right, here we go. This is probably the most important graph that you'll see regarding solar activity. So this is the adjusted solar polar field strength versus time. And it happens to be just almost exactly the same age as me. Now, I was born in 76, but it goes back, it's almost the same age as me, folks. I'm sure it's just a coincidence. It's a total coincidence. But in any case, this is the graph of the total field strength. So you've got two lines here. You've got the blue line and the red line. Those represent the north and south pole. The north and south solar polar field strength. And so the point is, we're not seeing a lot of data here. In fact, we don't even know what these solar polar fields were doing back in 1958, which was the point at which we saw the most solar activity that we've ever seen. So if you look at the total time frame of the solar polar fields, it does not even provide as much data as looking at the sunspot progression. So here's the sunspot progression. We're going to bring up the whole image here. There's sunspot progression going back to 1750. Let's put that on screen. And it turns out that if we go back 1,000 years, we see the same 11-year solar cycle. If you're able to explain the 11-year solar cycle, please let us know in the comments. Just kidding, folks. Just kidding. You won't likely be able to explain it. And if you tell me that it's because of the Birkeland current on which the sun formed, I'm going to ask you where the Birkeland current came from. So be prepared if you say something stupid. I'm going to say something smart in response. The point is, the most solar activity we ever saw was actually reported back here in the late 1700s. But in more recent memory, in the 1950s, around 1959 or so, was the biggest sunspot cycle that we ever really documented, sort of what you'd call in modern times. I mean, I'm not suggesting there weren't a lot of sunspots back here during cycle 3, as I haven't examined the historical proof myself. But in any case, this is the data that we have for the solar polar fields, folks, only goes back to here. That's all the information we have about the solar polar fields. So those who want to tie this together with total solar irradiance and make wild forecasts based on this little tiny chunk of data and the way the solar polar fields correlate to sunspot cycles, well, there are inherent problems with that, as you could probably imagine. And I'm just going to leave that there. And by the way, if you didn't see our video about 1,000 years of solar cycles, head to youtube.com/smashamash/playlists. If you click on playlists, you can click on it from the homepage, or you can go directly to it at youtube.com/smashamash/playlists. You'll find a cosmology segment. If you click view full playlist, one of the videos there, and we have this sorted a certain way. Let me resort that. You'll find a video on here about 1,000 years of solar cycles. Or you won't. What the heck is up with that? I couldn't imagine that something went wrong with the software. It was definitely user error. No, seriously, I think it was really user error this time. Anyway, we have commentary about the 1,000-year cycle in the daily space weather videos, which are, oh, there they are, right there. The daily space weather videos, in the last week, we made one right here. 1,000 years of solar cycles. So what happened was some Europeans found some wood which built structures at a very specific time. And this told them, what in the heck? Is that what I clicked on? That is certainly not what I clicked on. They found some wood, and the wood built structures that were built at a known period in time. And this information was used to date. Here we go. This information was used to date when those trees were harvested. And if you look at the amplitude over 1,000 years of solar cycles, you can see wild swings in the amplitude. Now, this is based on cosmic ray data. So this is assuming that the ratio of carbon-14 to carbon-12 in the trees that were used to build the structures in Europe is associated with solar activity. So we know that the amount of cosmic ray flux is inversely proportional to solar activity. So sunspot number is inversely proportional to cosmic ray flux. You see a lot of sunspots, you don't see a lot of cosmic rays. You don't see a lot of sunspots, you do see a lot of cosmic rays. So, but I would bring your attention to this, as this right here is super important. Look at the frequency. We see an 11-year cosmic ray cycle all the way through. Now, what does that tell you? I'm not going to connect all the dots for you in this video because we've got future content to make, but perhaps that will make some of our viewers connect some of the dots. And just for the record, cosmic rays aren't electric. They aren't electric until they show up around electrons. So if you think everything in the universe is electric, I'm going to do a little demonstration here for you. A little science demonstration, which maybe will get you to understand that all things are not electric. So here is a UVC light. This is electric. there are electrons changing states right here, and as they do so, they're emitting radiation. But more importantly, it's got batteries. Yeah, it's battery operated. It's electric. This glove right here, you see this white glove? This is not electric. Now, it does have some mylar fibers in it because it's one of those, like, I don't know if you can see that. It's one of those shiny gloves for the extreme cold weather system. It's for extremely, extremely cold weather. And this is not electric. And people may say things like, well, you're not falling through the floor because everything's electric. And I'll say, it's not electric. And they'll say, but electrons are holding the molecules that make up the floor together, which that's what causes the chemical bonds that make up the floor that prevent you from falling through the floor, and yada, yada, yada. That doesn't make the floor electric. Your floor is not electric, folks. You could say it's electronic. And this brings me to a point from astronomy class in the mid-90s. So I've been studying astronomy for, let's just say, quite a while. And in the mid-90s, I noticed something very weird. In astronomy class, astronomy professor Harry Loomis stated something very weird. And I was wondering what it was he meant. Of course, now I know exactly what he meant, and he was exactly right. Because what he said was, there's a lot of theories out there about the universe, how it forms, and cosmology. I consider it a major in stellar cosmology. And anyway, what Harry Loomis said was that when asked if the universe is electric, he said no. And then people said, what about stars? Are stars electric? And he said, no, but you could say they're electronic. And back then, I didn't understand the physics well enough to understand what he meant. And nowadays, it's super obvious what he meant. And it's because all theories of solar behavior are halted by one thing, folks. One thing. Where do all those electrons come from? That's the question. That is the question. It's a question that plagues mainstream astronomy, and it's a question that plagues the electric universe. Because if stars are formed on a Birkeland current, where does the Birkeland current come from? But most importantly, where those electrons come from is explained by one theory. One theory in cosmology, or you could say heliophysics, or you could say astrophysics, or you could say basically the physics of all natural sciences. There's one theory that explains it. Leave us a comment if you know which one it is. And which brings me back to another important point. Coronal holes. And I'm not going to go into why sunspots are dark, but this one theory not only explains how coronal holes work, but also why sunspots are dark. So if you know the theory, feel free to leave a link in the comments, or tell your friends and foes all about it. I'm just going to keep it a secret because so few people seem to understand it. Also, if you're new to the videos and you're not familiar with David LaPointe and his primer fields theory, the theory of primer fields, the magnetic fields associated with his specifically oriented magnetic field cups, the primer fields. I don't know. I'll just call it the primer fields. If you're familiar with that, leave us a comment. David LaPointe does not believe stars are electric, and neither does Dr. Pierre-Marie Robitaille, because stars do not appear to be electric. While there are electric things happening on the surface, they don't appear to be electric. So, I don't know. Deal with it. We're going to blow this up so it looks cooler. There we go. And we're going to show these coronal holes. So, coronal holes are super interesting, folks, because coronal holes are areas of actually lower temperature, but from our perspective, higher pressure. These are like low pressure systems for the sun, folks. Why? Because there's material spewing out of this coronal hole. all the time. There's material just spewing out of it, and some of it is headed right toward you. And there's a reason why it's doing that, and we won't be explaining that at all in this video. It's for future videos. This one was about analyzing the coronal mass ejections. So let's get back to that. I'll see if I can get even more current images here of Stereo A's space weather beacon. If you're wondering where that is, it's located here at Lagrangian point 5. It's looking off in this direction, in which the Earth would be off to your right. It's one of the most important tools for noticing coronal mass ejections. And we've got some newer data here. It looks like that may have completely released now, as the last frame looks like it doesn't show any difference imagery there. No, it might still be erupting. I'm not exactly sure. Let me see here. Let's bring up the last frame so it stops moving. There's the last frame. I still see some brightening. So it looks like a second event has already kicked off, really, but it looks like a second event is happening here. We see another bright bubble forming right there. And so we'll probably have to make at least a third video today. Also, we'll probably make one with close-ups, some visually pleasing aesthetic videos that are just close-ups of the local yellow dwarf and so on. Let me put your chats on the screen here. I just want to bring up a better background before I display your chats once again. So just bear with me a quick moment. I'll put up 211 angstroms. We haven't viewed this one yet today on the channel. And if you're wondering what my initials are, they are DJN. I have DJN skills. I don't know. They're just innate. It doesn't require practice. Leave us a comment if you're viewing our videos during choir practice. Anyway, there's a great view of the local yellow dwarf. Some massive coronal hole systems here. And they're of opposite polarity, by the way. This one here is South Pole, and this one here is North Pole. As the North solar polar field has stretched way down, and the South polar field coming up, as we watch the solar polar field reversal happen in essentially real time. Okay, the data is a little more than 8 minutes old because, you know, it takes 8 minutes for the light to get here, and yeah. No conversations about time travel coming up on the channel. Please leave us a comment if you've taken a course in temporal mechanics. It's a real thing at certain places. By the way, you can get all of the course material at MIT for free online. I don't know if you were aware. If you think you need a degree, I don't know what to tell you. Either you know the information or you don't. So thanks for commenting once again, Pop and Chicken and Mandy and Pull My Finger and Patman and Adrena Lee. I like that name, Adrena. It's a great name. Adrena Lee, who says 76 was a good year. We don't fall through the floor because we collectively believe it is solid. Am almighty familiar with LaPointe. I hardly understood it, though. Yeah, the LaPointe stuff is pretty serious. And when it comes to things like the cosmological implications of if LaPointe is correct about LaPointe's cosmology are pretty serious, too. Again, thanks for leaving comments, everybody. Patman, are you a new viewer? Thanks for dropping us a line from Alberta. What's the weather like in Alberta? Do you have a lot of snow on the ground? We've got an ongoing snowpack here for like a month. We got an instant glacial blizzard where we had 2 storms overlapping each other, one with a very strong wind and a fine snow from the east. That was the cold system from the Arctic. And then we had another cold system coming from the south, which was wet snow, and it just formed into an instant glacier. Not ice, but chunky snow, man. You know, the Inuit people, the Inuit people have a word for that kind of snow. I have no idea what it would be, but when I was outside, I realized that there were two storms at the same time. A lower level high over New Jersey and a very powerful low pressure system over the Ohio Valley that struck us here in Lehigh Valley, Pennsylvania, all at the same time. It was pretty epic. Pretty epic. It was a legit blizzard. And I believe it was the third biggest one-day snowfall on record here. I also got to experience I believe it was a 1983 blizzard, which held the record forever. And there were also two other really large snowfalls here in the past couple of years as well. Strangely, last year we saw almost zero snowfall for the entire Boston to Washington, D.C. corridor. So it was, it's been an interesting and chaotic few years of weather. What say you? I don't know about your quantum mechanical view of why we don't fall through the floor Adrena. We don't fall through the floor because we collectively believe it's solid. I don't know, man. I think if a guy swings a bat at my head, my belief in the bat's solidity matters not if my skull is getting hit by a bat. In other words, if I'm not looking, do I believe the bat is solid? And if a tree falls in the woods, how much is the cost of tea in China? How about another view? This is one of the best ones, folks, the composite 171 angstroms plus colorized magnetogram. It'll show you the fields, some filaments, and some magnetic behavior of the ions of this particular iron. And this particular iron is, I think it's iron 19. Oh, iron 9. So 8 times ionized iron. For some reason, that particular iron likes to orient around magnetic fields. So a great example of the way the plasma in the corona orients to the magnetic fields. You can see the setting there of sunspot 2804. It's about time to close this thing out, folks. If you have any other comments you'd like to leave them now, because we are out of here. Thanks again for tuning in, and we'll be keeping you posted, probably with 1 or 2 more videos today on YouTube about the ongoing coronal mass ejection situation. So again, I've been your host, Dan, a.k.a. smAsho. Thanks again for tuning into the Smash News Network. And I am signing off. We'll see you next time on The Daily Space Weather.